So we need to start off by defining. So inverse trig, this is where on your calculator and stuff you're using the -1 sign. This is where you put in the thing and you get the angle back for your answer. So we need to start off by defining it, because the problem is when you do inverse trig, it's not a function. And maybe I'll start off with the graph to show you this, and then we'll move on to the next thing, because maybe I put it in the wrong order. Maybe it's better to show it to you as a function or as a graph. The problem is, okay, so this is our graph of sine. Whenever we do inverse trig, what it does is it takes this graph, and this isn't totally correct, but it takes this graph and it goes like this. So it fails the vertical line test. It's no longer a function. That's bad, because that means we can't use it in a calculator. We can't use it for anything. If I plug in a number, I get infinitely many answers for every single number I plug in. So that's bad. So what we do is we take our graphs and we trim them down. Now with tangent, it's not a problem. This is tangent. With cosine, we trim it down like this. With sine, we trim it down like this. Then we have functions. Once we have functions, that means we can use it in calculators, and we can use it elsewhere, because we will always get one answer. So what we need to talk about is how we trim that down, because that's very important. Because you have to know, wherever you get an answer, what kind of answer are you going to get? Why do you get that type of answer? Okay, so to define it, what we're going to do is we're going to go back to the unit circle. Now, whenever we do this, we always want the first quadrant. So let's start with sine. So I'm going to do this. I'm going to start with sine. What we want is we always want the first quadrant here. Because we define everything based off this first quadrant. Now, since sine is based off of the y values, if I go over here to the second quadrant, I start repeating. Because the y values repeat, don't they? So what I do is I come down here, because I want to make sure I get all the possible y values. So I already have all the positive y values between 0 and 1. To get all the possible negative y values between 0 and -1, I would come down here. Because if I go over here, I'm repeating all the y values I already had over here. Does that make sense? Yeah. So, sine inverse is, and then I don't have to keep going over here, because again, if I go over here, I'm repeating all the values in between -1 and 0. So sine inverse is defined in between -pi/2 to pi/2. I should put that as y, sorry. So whenever you plug in numbers, you will always get back a number in between pi/2 and -pi/2. Or if you're looking at degrees, you'll always get back a number in between -90 degrees and 90 degrees. So if you know that you're doing this for a triangle and you know that your triangle angle should be an angle between 90 and 180 degrees, you're not going to get that angle. What you're going to do is you're going to get one of these angles, and then you're going to have to know that you're supposed to get one of these angles and translate it. And we'll talk about that later. That comes up in chapter 6. But what's important right now is that you know the area where your answer comes from. Okay, so tangent. Let me do tangent, or not tangent, but cosine. Let me do cosine in another color. So again, cosine, I want the first quadrant. Now, it'd be nice if we could just define everything between negative pi over 2 and pi over 2. Unfortunately, that doesn't work, because if I go back down here, for the x values, these all repeat. Because x is still positive over here. So for cosine, to get my negative values, I come over here. So for cosine, for the x values, this gives me all the values between 0 and 1, and 0 and negative 1.
What about tangent?
We'll get to it. So cosine is defined from 0 to pi, or 0 to 180 degrees. So cosine actually works really great for triangles because we can get all the angles that we need for a triangle. So tangent would work in either one of those situations, right? Because tangent is y divided by x. So in some place long ago, someone decided tangent is going to be defined. See, tangent is going to be defined in the same area as y is, or sine is defined. I do not know who decided that. I do not know why they decided that. My best guess is they decided to define it in the same place as sine because sine is in the numerator, but I don't know. So tangent is the same as sine. It could be the other two quadrants. It really could be. But that's not how it's defined. Yeah. With tangent, I just wrote the same thing I wrote underneath sine. Okay, so that's your area of definition. So I'm going to refer back to this whenever we're doing some of the examples. Okay, other part of this is I just want to go over some terminology. Where we're doing this, on your calculator, you're going to see it represented like this. It can also be represented like this, which your book likes using a lot. That's how it's pronounced, is arcsine. You put the ratio on the inside and you get the angle back as an answer. And again, we can do the same thing with cosine or tangent. The thing to remember with the -1. -1, unfortunately, means several different things in math. This -1 means the same thing as inverse. Just like whenever we were doing inverse functions. So we put that little -1 up there last semester when we were doing inverse functions to mean the inverse of x, or inverse of f. So that's what the little -1 means. So it's not an exponent. All right, so we already talked about the graphs. Let's go through some examples. Most of these examples should be fairly quick and straightforward. Biggest thing with these is you just have to remember where your functions are defined. So if I'm looking for arcsine of 1/2, what that means is I pull up my graph or my chart. Sine is the blue one, so I look for where sine would equal 1/2. So sine is y. So sine equals 1/2 right there. So my answer would be pi/6. Does that make sense how I got that? So arcsine, remember sine is the y values out of these ordered pairs, right? Arcsine is defined on the blue area, so from -pi/2 to pi/2. So I look in this area for wherever the y value of the ordered pair is equal to 1/2. So it'd be right here. And then my answer is the angle. So either in degrees or radians, depending on wherever it asks for. So my answer to this could either be pi/6 or 30 degrees. So on the next one, negative or arc cosine negative radical 3/2. So cosine's in the red area. Cosine is the x value, so I look for the x value that is negative radical 3/2. So that'd be 5 pi/6 or 150 degrees, whichever one you want to put. Unless your book tells you which one to put. Or I tell you on the test which one to put. Okay, sine inverse of radical 2/2 would be what? Yeah, 45 degrees or pi/4. So again, you just go back to the chart, find square root of 2/2 for the y value, and your answer is that angle. Okay, so they're the same thing. No difference. I'm just going to keep bouncing back and forth on here just because there is no difference. Your book bounces back and forth between them also. Okay, so let's do some weirder ones and slowly get into different types and harder ones. Okay, so where would cosine 0 be? So cosine is the x value. Where does the x value 0? Pi over 2, or 90 degrees. Okay, where does sine equal -1? So sine is the blue area. Where does it equal -1? Okay, 3 pi over 2, but remember, since we're going backwards from 0, that's not 3 pi over 2. Negative pi over 2. Okay, where would tangent equal -1? Tangents are a little bit harder because you have to use your division. Yep, -45 degrees. So the place where you get 1 is where they're the same. So the place I get -1 is where one of them is negative, which would be down here. Since I'm going backwards from 0, I would be at -45 degrees or negative pi over 4. So this would be -1, right? Whenever I divide them. Okay, I'm going backwards from 0, pi over 4. Or 45 degrees. Nope, degrees would be -2. If I was doing this in degrees, it'd be -45 degrees. Because in order to get to the positive degrees, I'd have to go all the way around this way. I can't do that because that goes past my shaded area. Okay, arctangent of radical 3. So in order to get radical 3, I'm doing y divided by x. So that means the radical 3 would have to be on the top. So I need the radical 3 to be the y value. So that'd be pi over 3. Because to get the radical 3, I need it to be divided like this. So that means my y value has to be radical 3 over 2, so that would give me pi over 3 or 60 degrees. So that's why the tangents are a little bit harder. And for some people who have difficulty with it, what I suggest is going through and taking and dividing these. Divide each one and put it out to the side. So if I divide these two, I get radical 3. If I divide these two, I get 1. If I divide these two, I get radical 3 over 3.
What do you mean by divide by?
Because with tangent, you have to take y divided by x.
Okay.
So if I take y divided by x, it looks like this, which would give me radical 3 over 2 times 2 over 1. Those will cancel, so that just gives me radical 3. So at this point, tangent would equal radical 3. So then this one would be negative radical 3 over 3. This one would be -1. This one would be negative radical 3. So if you have problems seeing the division, you could always do that. Okay, arcsecant. We haven't talked about arcsecant. How do I get arcsecant? Yeah. 1 divided by arc cosine of negative what? -2. Where's cosine equal -2? No, that's because this isn't how you do it. No, you do it like this. You switch the number inside, upside down. Because I was letting you guys tell me what to do. You flip the number inside, upside down. Huh? You don't with the arc ones. You don't flip this upside down. You flip your number inside upside down. Negative what? Yeah. Flip your -2 upside down. Yeah. So I'm doing cosine. So go to the red area. So it's right here. So I get 120 or 2 pi over 3. So arc cosecant of square root of 2, what would that be? That'd be arc sine of 1 divided by square root of 2, which is what? Square root of 2 over 2. Yep, which is 45 degrees, or pi over 4. Okay. How about arc sine of 1/2, but I want to change where I'm defined at. I want you to find arc sine in between, that should have an equal sign on it, 1/2 from 5/2 to 7/2. Well, we just got to go around the circle more times. So 5/2 would be where? Yeah, 5/2 would still be up here. Because this would be 1, 2, 5/2 is 2.5, so this would be 2.5. 7/2 would be where? Yeah, it'd be down here at the bottom. So I'm looking for 1/2 somewhere over here. So it'd be right here. Now, I need that in between these two, though. But it's in pi, so you need to do that. So this is 1 time around the circle, right? So what I need to do is I need to take 5 pi over 6 plus 1 time around the circle. Does that make sense, why I did that? Huh? Why 5 pi over 6? Okay. So I found these two. These two are here and here. So I found 1/2 in between those two is right here, which is at 5 pi over 6. Now,